So welcome all. In this class, we are going to discuss about the solution of swing equation by point method and Runge-Kutta method. So before going into that, I hope you all remember what is swing equation. Swing equation is m into d square delta by dt square is equal to Pa, where m is the angular momentum and Pa is the accelerating power. So the swing equation is a second order differential equation. So to solve this differential equation, we have to apply any numerical method. And if we solve the swing equation, we will get the values of delta, how the values of delta changes with time. That is, the solution of swing equation gives the change in delta with time. That is, if we plot a graph, we can see that how the value of delta changes with time. So, by solving the swing equation, we can say about the stability of the system. That is, if delta goes on increasing with time, then we can say that the system will be unstable. If the value of delta increases and then decreases, then the system will be stable. So, this swing equation is used to determine the stability of the system, and by solving the swing equation we can say that the system is stable or not. Since it is a differential equation, we have to apply any numerical methods or iterative methods to solve the equation. So, in your syllabus, there are two methods mentioned. One is point by point method and the other is Runge-Kutta method. So, first we will discuss about the point by point method, or it is also known as step by step method. So, by using the step by step method, good accuracy can be obtained, and it is also easy for computation of delta. It is an easier method, and we can achieve a good accuracy by this method. So, before going to the method, some assumptions are made in this method. First one is the accelerating power Pa is constant in an interval, and compute the angular position and angular velocity at the end of interval. That is, in step-by-step method, we are dividing the whole time into small intervals. That is, if we have to find the change of delta after 10 seconds, then we divide this 10 seconds into small intervals. That is, first interval is 10 seconds, then next interval is 10 seconds. Like that, we divide the total 10 seconds into small intervals. So, the first assumption we are making is, we assume that the accelerating power in this small interval is constant, and with this accelerating power we find the values of delta and omega, that is angular position and angular velocity at the end of that interval. That is, if we have to find the value of delta after 10 seconds, we would divide this 10 second into small intervals. Let the one interval is 5 seconds. So first interval is 5 seconds. So we assume that the accelerating power in this 5 seconds is constant, and with this accelerating power we find the value of delta and omega at the end of that interval. Now, with this angular position and speed, that is, with this value of delta and omega, we find the accelerating power for the next interval, and this accelerating power is taken constant for the next interval, and we will find the value of delta and omega for the end of that interval. And this process continues until the required time is reached. So hope you understand. First we divide the total time into small intervals, and in one interval we assume that the accelerating power is constant. With that accelerating power we find the value of delta and omega at the end of that interval, and after getting the value of omega and delta at the end of interval, we find the accelerating power for the next interval, and we assume that this accelerating power is constant for the next interval, and with this accelerating power we will find the value of omega and delta for the next interval. This process continues until the required time is reached. So for calculating the value of delta and omega for a particular interval, we are using some equations. So to get this equation, we start with swing equation. We know that what is swing equation? Swing equation is m into d square delta by dt square is equal to Pa. That is d square delta by dt square is equal to Pa by m. So if we integrate this with respect to t, we get d delta by dt equal to omega. That is d delta by dt is angular speed, that is represented by omega, which is equal to, if we differentiate Pa by m, we get Pa by m into t plus a constant omega 0 initial value. Now once again integrating, we get d delta by dt. If we integrate this, we get delta is equal to, if we integrate this, we get omega 0 t plus Pa by m into t square by 2 plus delta 0, that is the initial value. So here delta 0 and omega 0 are the values of delta and omega at the beginning of the interval. Now we denote n, we'll let n denote the quantities at the end of the interval. If you are taking an interval and the letter n denotes the value of the quantities at the end of the interval, and n minus 1 denote the quantities at the end of n minus 1th interval, and delta t is the length of the interval. Delta t is the length of the interval. So from this equation we can write omega n. What is omega n? That is the value of omega at the end of nth interval will be equal to omega n minus 1, that is the value of omega in the last interval, that is omega n minus 1, plus Pa of n minus 1 by m into delta t. Once again, and omega n equal to omega n minus 1 plus Pa of n minus 1 by m into delta t. Similarly, delta, what is delta n? Delta n will be equal to delta n minus 1 plus omega n minus 1 into delta t plus Pa of n minus 1 by m into delta t square by 2. So these are the equations for omega n and delta n at the end of nth interval. Now we can calculate delta omega n, that is change in omega occurring in the nth interval. Delta omega n will be equal to omega n minus omega n minus 1. That is, what is the change of omega taking place in the nth interval will be equal to the value of omega at the end of nth interval minus the value of omega in the n minus 1th interval. That will be equal to Pa of n minus 1 by m into delta t, because omega n minus omega n minus 1 will be equal to Pa of n minus 1 by m into delta t. Similarly, delta n will be equal to delta n minus, we have to take this to this side, minus delta of n minus 1, that will be equal to omega n minus 1 into delta t plus Pa of n minus 1 by m into delta t square by 2. Now, for the preceding interval, if we write delta of n minus 1, what will be delta of n minus 1? Here, we have written delta of n. We have to write delta n minus 1. What will be delta of n minus 1? Delta of n minus 1 will be equal to delta of n minus 2 plus omega n minus 2 into delta t plus Pa of n minus 2 by m into delta t square by 2. That is what written here. Now, equation 1 minus 2 gives delta n minus 1 will be equal to delta n minus 1 minus delta n minus 2 plus omega n minus 1 minus omega n minus 2 delta t plus delta t square by 2m into Pa of n minus 1 minus Pa of n minus 2. Now this is what delta n minus 1 is delta n, and this is delta n minus 1, and this is delta omega n minus 1 into delta t plus delta t square by 2m into Pa of n minus 1 minus Pa of n minus 2. Comparing equation 3, we get omega n minus 1 minus omega n minus 2 will be equal to Pa of n minus 2 by m into delta t. That is delta omega n minus 1 is Pa of n minus 2 by m into delta t. So substituting this value, delta omega n will be equal to delta n minus 1 plus, instead of this we can write Pa of n minus 2 by m into delta t into delta t. That is, we are substituting this value in this equation plus delta t square by 2m into Pa of n minus 1 minus Pa of n minus 2. Therefore, delta n equal to delta n minus delta of delta n minus 1 plus delta t square by 2m into Pa of n minus 2 plus Pa of n minus 1. So this is how the change in delta for one interval is calculated. So this equation gives the increment in delta during any interval in terms of increment for the previous interval. This is how the value of delta is calculated for the next interval. That is, change in delta is calculated for that interval, and this change will be added to the initial value. Then we will get the new value of delta for that interval. Then again delta, change in delta for the next interval is calculated, and the procedure is repeated. So this is how we solve the swing equation by step method. That is, this is how we get the value of delta for different intervals, and after getting all these delta values for various interval, we plot this value of delta, and if the value of delta goes on increasing, then the system will be unstable, and if the value of delta increases and then decreases, then the system will be stable. This is how the stability is checked by solving the swing equation. Now we will see another method of solving the Runge-Kutta method. I am not going into the details of Runge-Kutta method. Normally only theory questions will be asked from this section. The problems will not be normally asked. So just study the procedure and steps for this Runge-Kutta method. So in Runge-Kutta method, first step is, if a system is given, we have to do the load flow solution of that equation of that system, and we have to find the generator induced voltage E. That is the first step. First we have to do the load flow solution. After doing the load flow solution, we will get the voltages, bus voltages. So we will find the induced EMF of the generator, and we will find the maximum power transferred under pre-fault condition. That is, we find Pmax1. After getting Pmax1, we can find delta 0, that is initial value of angular position, that will be equal to sine inverse of Pm by Pmax1. Now we assume that the fault occurs in the system, and we calculate Pmax2 during fall condition. We find Pmax2 during the fall condition. Then after that we are going for the iteration. That is, we first take the iteration count k equal to 0. That is, we are going to find the first iteration k equal to 0. Now in Runge-Kutta method we have to calculate 8 constants. These constants are k1, k2, k3, k4 and L1, L2, L3, L4. That is a procedure for Runge-Kutta method. I'm not going into the details. We have to find 8 constants while we solve a problem using Runge-Kutta method. These are the constants, and these are the equations for finding these constants. So after getting the value of the constants, we will find the value. We will find the change in delta and omega. That is, delta of k is equal to, this is also the equation which is used in Runge-Kutta method. This is how we calculate the change in delta and omega. Now after getting the change in the values of delta and omega, we can find the new values of delta and omega after that interval, that is delta of k plus 1 and omega of k plus 1. And next step is calculate the new value of E, induced EMF. After getting the value of delta and omega, we calculate the induced EMF E. Then next step is we have to check whether we have reached the required time. That is, we have to check whether T is less than Tc. If T is less than Tc, that is required time is not reached, then we have to increment the time count and iteration count. Iteration count is k equal to k plus 1, and again we have to perform the step 5. We have to again calculate this constants and new values of delta. If T is greater than Tc, that is required time is reached, then set k equal to k1. That is, we have to increment the count, iteration count, and the next step we have to check whether the maximum required iteration is reached. If it is reached, we can terminate the process. If it is not reached, we have to again do the step 5, and we have to perform the calculations again and again. So this is how the swing equation is solved using Runge-Kutta method. Just study these steps. No need to go into the details, just study the steps only. Normally some theory questions may be asked from this section. We are not expecting any problem from this section. So hope the 2 methods for solving the swing equation is clear. So thank you.